Now, deep learning. So, artificial intelligence we spoke, machine learning is part of artificial intelligence where the paradigm shift has happened already. Meaning, given the rules and answers, given the input data and answers, we are supposed to come up with rules. That is machine learning. Good. Now, deep learning is again, there is no paradigm shift, right? There is no paradigm shift. It also uses the same paradigm. It also takes input and answers or labels or tags and comes up with trains itself and comes with the rules. And then based on that, it can start predicting, right? So there is no change in that. But what the change is, there is an emphasis given on successive layers of increasingly meaning representation. There we have spoken about coordinate change. There is just one representation, right? So it might happen that the machine learning may directly understand the problem within one layer or within one shot and come up with that kind of rule, right? Or sometimes it's not so easy, and actually it turns out that most of the times deep learning works more efficiently, where we say that for me to able to come to a particular kind of transformation, I might have to go through some successive layers of increasingly meaningful representation. Meaning every layer is meaningful in itself. It is creating some representation based on which some learning is happening, and then it is getting transformed into the next representation. Some other learning is happening, and based on that, it is transforming into some other representation. And these could be multiple layers. And the models generally have layers beyond hundreds, right? So that's why it requires huge computation. Now, the diagram I have shown, if you see on the leftmost, there is input layer, and in the middle, there are three hidden layers, right? So these three layers are actually not seen by user. User is just seeing the input layer and the output layer. But these are the deep neural network layers, right? Which is why the term learning comes, because there is a depth. So in this case, the depth of learning is, one, two, one, two. There's one representation, two, three, four, right? Four transformations are happening. So depth is four. There are four successive layers, right? So this particular thing, what is happening is this is called fully connected representation, meaning every node in one layer is connected to all the layers in the other node. Meaning what we are saying in a way is that every node in one layer is affecting or getting transformed into somehow or other into another layer in the next node. It doesn't have to be like that, but mostly we use fully connected layers. So in this case, that's what is happening. So we are transforming. If you see, the number of nodes also have increased in the second layer. That means the representation is changing, and the representation might increase the number of nodes, sometimes might reduce also, whichever can happen. And then there is another level of transformation, another level of transformation. So how do we understand this with some example, right? So for example, if I'm doing, let's say, if I'm trying to classify an image to find out what is a digit. If let's say I'm getting, my input is a digit written on a piece of paper or an image, right? A digital image. I mean, a digit on image, right? So, and my task is to show, tell what that number is. Let's say single digit number, right? So in that case, the transformation of that happens in multiple stages, right? The representation is learned in multiple stages. One representation might be to extract the feature of the edges, right? That could be one thing, right? And another thing could be the dark ones, right? So these kind of features has to be extracted, and then based on that, these hidden layers there is a transformation happening within these hidden layers. Even more simpler example, if you want to take the example of let's say uh, you know weather prediction, right? So let's say there are multiple parameters like humidity, precipitation, the distance from the equator or distance from North Pole, right? And what time of the month it is, what day of the time it is, everything. Let's say there is a lot of data, and based on that, we have to predict weather. So in this case also, we might have, we might take these inputs and we will have some answers. We'll train the model with these things. with multiple layers in between. So the assumption is that directly these factors may not affect the rain, but these factors will be transforming into some other factors, and so on and so forth, and finally that affects the final outcome, will it rain or not. So that's the understanding. So in this way we can think of, right, people say that this is inspired, I mean it is actually inspired by the understanding of the brain also thinks that way. Brain tries multiple representations and sees what is the data that is fitting to these representation, and based on that it does the decision, right? But some people think that this is how the brain is also modeled, meaning people think that there are these neural networks are also how the brain is working, but there is no evidence for that, like I've told before also, right? Because deep learning is purely a mathematical framework for learning representations from data. Given data, a mathematical framework is created, which is pure maths, to learn the representations from the data. And once the learning happens, then given some data, we can process that data for the output, right?